Hi everybody, John Sarton here with the Rio Grande Jewelry Tech team. Welcome to part 2 of my 3-part series on how to recycle metal. In the last video, we took silver scrap and turned it into an ingot. In this video, I'm going to take that ingot and I'm going to turn it into usable sheet. Let's get started. Okay, here's the ingot that I poured in part 1 of this series. What I'm doing here is I am actually removing, just filing off, and I'm going to polish the surface of the ingot just so that I can see the composition of the ingot. If there are any oxides that I can't see that is underneath this, this kind of casting scale here, I want to know before I process it any further, because if there's any oxides in the surface of the ingot, they will cause problems in further processing. So I'm just going to take a little bit of time and I'm going to file this down. I'm just going to use progressively finer files. So I'm starting off with a 0 cut hand file, and then I'm going to go to a 2, and then I'm going to go to a 4, and then I'm going to go ahead and clean it up enough that I can actually put a polish on it. So I spent about 15 minutes and I cleaned up both sides of the file, took it to 400 grit, and then just went ahead and went to my polishing motor real quick and hit it with a yellow treated buff and some Fabuluster. I'm not trying to get a super high polish. This isn't a finished piece. All I wanted to do was I wanted to actually see the surface of the metal. And if you guys have ever made a piece, polished the piece, and found a bluish gray hue or stains in the piece that you just could not polish out, that is fire stain, and that is oxide that's in the surface. So if that's the case on an ingot, if you have oxides in your ingot like that, then you'll never be able to get rid of them. And I don't know about you, but I've got a more processing here to do, that I'm going to have to do some forging, and I'm also going to have to do some time on the rolling mill, and I really don't want to be spending a whole lot of time rolling this sheet out if I know that the sheet's not going to be quality sheet in the end. So even though this looks like it's time consuming, and by all means, you don't have to do this. This is how I do it. This is my own process that I do. But in the end, it definitely does give you a better billet or a better ingot, and it gives you a better sheet as well. Okay, so what I did here is removed the casting scale off of the edges of my ingot. And what casting scale can actually hide cracks, and I really don't want any cracks in the edge of the ingot. If there are cracks there, then that sets up stress risers, and that would be a point of failure. So as you further start to process the billet, either by forging or by rolling in a rolling mill, that is where cracks would start, and then they could actually progress down into the ingot. So now that I've got that looked at, it looks good. I don't have no cracks at all. I'm going to cut this off here, and then I'm going to take it and start forging it. So this is the way that I create sheet out of an ingot. Some people will go directly from the ingot right into the rolling mill and start rolling their sheet. But I like to forge my ingot before I go to the rolling mill. And I forge it down about half the thickness of the ingot. There's a number of reasons that I do this, mainly because this is the experience that I've had in over 20 years of doing this. I found that I get a better quality ingot and better quality sheet whenever I do forge it prior to going to the rolling mill. And it reduces the crack formations that that can be caused by going directly to the rolling mill right from ingot stage. That's because forging, even though you are hitting it with a hammer, is a gentler way of thinning out the ingot than a rolling mill is. I'm going to use some clay here to explain that. So this one right here, I used a hammer on it, okay? And you can see that I've started to decrease the thickness, but I'm only working one side at a time. Now, I went ahead and ran this through my rolling mill, and both of these are fairly exaggerated, but I went ahead and ran this through the rolling mill, and you can see that in a rolling mill, you are actually thinning out both sides of the sheet at the same time. So this puts an enormous amount of stress on an ingot. And whenever an ingot is freshly poured, the grain structure is really, really large inside of the ingot. So there is more of a potential for a ingot to fail or to crack on you, to start cracking, whenever your grain structure is really, really large. By using a hammer and you are breaking this grain structure down slowly, and it is becoming more aligned in the piece itself, it's going to make the ingot more structurally sound. Up to you as to which way you want to run with it, but I personally found that forging the ingot prior to going to the rolling mill is much more advantageous to good sheet in the end. So I'm going to forge my ingot. You need to be really comfortable at your anvil so that whenever you are striking the metal, you're not putting a lot of pressure on your joints. So it's nice to have anything that you are forming on at a level that is comfortable for you. There is no specific height. There is no recommended height. It just depends on you. Okay, so here we go. Now I'm using a fairly large hammer, and I'm letting the hammer do the work. I'm not putting my arm into it. I'm lifting the hammer up, and then I'm dropping the hammer down. And I want to work all the way across the billet this way, or the ingot. And I'm trying not to hit the edges so much. I'm trying to stay in the middle of the ingot, and then I'll work the edges down in just a few seconds here. Now, whenever I get to the edges, I'm going to lighten up the blows by not raising the hammer as far. If you hit really full force on the edges, you can actually start the edges cracking, and I don't want to do that. Now I flip it over, and I will do this side. Now you can see that I'm raising my hammer a lot more, but I'm just letting the hammer drop down. Now the reason that I am forging it this way is because I want to widen this ingot out. And I want to get the ingot about even in thickness. Right now, just by eye is all you need. It looks pretty good. Now what I'm going to do is, one thing about forging, a difference between forging and rolling, is forging, you can actually change direction, where with a rolling mill, you don't necessarily want to roll it in this direction and then roll it in this direction until you anneal. So with forging, you can get by without having to anneal the piece, and you can thin the piece out a little bit more. What I'm going to do here is I'm actually going to go kind of at a diagonal now, and then it should be about time to anneal, because that should be right about half of the actual starting thickness. Now what I'm going to do is I'm going to turn my hammer over and I'm going to flatten this out as good as I can. I want to just kind of planish the ingot and get rid of any of the high spots. Okay, let's go ahead and measure this. So it looks like I need to go just a little bit more. It started out at about 140 thousandths, which is about 3.5 millimeters. So I want to go a little bit more to meet my 50%. So what I did here is I went ahead and I did another full round of forging, and then I planished it. So we're looking at 70 to 80, which is about half. I'm going to go ahead and anneal this, and then I'll progress to the rolling mill. Okay, so I'm going to anneal this piece now. The first thing I'm going to do is I'm going to dip it into some barrier flux, boric acid, and alcohol. I'll move my barrier flux out of the way, and then go ahead and let that alcohol burn off. Barrier flux is pretty important to use on something like this, because as you are annealing, you are building oxides, and you want to reduce the amount of oxides that you can actually build on the piece during the annealing process. And you definitely don't want to over anneal this piece, because if you start to over anneal, then you will start to build oxides inside of the ingot. So what I'll do is I'll do this once, and then I actually like to use a brush and give it a few more coats, just so that I know that I have a good surface. It could have picked up a little bit of oil along the way, and what oil will do is it will actually separate barrier flux. Time to anneal. So I'm not going to just bring this up to where I see that dull cherry red color that we are always looking for, because it's really hard to see in the light, and I'm not going to turn the lights off for this. But there's another way that you can tell, and that is whenever the surface of the metal reflects back an orange flame back towards the torch, and you'll be able to see that here really good. So go ahead and fire it up, and we'll start heating this piece up. Now just watch really closely as it nears annealing temperature. You're going to start seeing that orange flame bounce off of the piece. And there it starts right now. And there it is. We are annealed. So now I'm going to take it, quench it, pickle it, and then go to the rolling mill. I have my piece, it's annealed, and it's ready to go into the rolling mill. What I like to do is, you can see that this end of the billet is a little bit narrower than this end. So if you try to put a straight edge on it, you're going to see that the rollers will actually catch on this high spot before they really catch on this high spot. Now you can put it in just like so, snug it up to the rollers so it'll feed fairly evenly. However, since this is longer, this is going to continue to get longer than this side. And if you have ever had in a rolling mill, if you've ever had your sheet curve as you were rolling it, this is one of the causes to that curving. So what I'm going to do, I'm just going to go ahead and smooth this out, get it as close as I can to being straight. It doesn't necessarily have to be square, but you want it to be straight. So I'm just going to chuck it up in my Benchmate, use a file on it, and start to take this edge down a little bit and even this line up. Another thing is inspect your edge and make sure that there are no cracks in your edge. Because if you don't take care of your cracks now, they'll get worse whenever you go on into the rolling mill. So that one looks pretty good. I'm going to go ahead and flip it over and straighten out the other side, and then do my edges here and make sure there are no cracks there as well. I'm going to take it to the mill. First thing I do is I'm going to adjust the rollers to the height of the sheet or of the ingot, and I'm going to do what's called a dead pass. So I'm going to put the sheet in, and I'm going to close the rollers until I can't pull the sheet out. And then I'm going to look at the top of my rolling mill, and most rolling mills will have a dial like this or some form of a scale, and I'm going to read where it's setting. And then I'm going to back off the wheel, pull out my ingot, set it back on that number, and then I'm going to add 5 units. So that was from 20 to 25. Now, I don't want you to think that this is any form of exact measurement. It's not millimeters, it's not thousandths of an inch, and I don't want you to think of it in that way because different rolling mills have different scales on them. But they're always going to have units or little tick marks that you can count. So the main thing is I don't want to take too big of a bite whenever I begin. So whenever I set the dead pass, I set it to the highest point on the ingot, and then I'll add 5 units and I'll roll it through. If it's not enough, no harm, no foul. If it's too much though, you can start to increase stresses in your billet, which will then lead to your billet failing. So I added 5, and now I'm going to do a pass. So I went ahead and I just took a little bit, and you can kind of see that this area was touched by the roller, but the edges around it were not. And that means that the billet was not completely flat. It was not completely one dimension throughout the entire thing. And this is why I'm taking little bites, is I don't want to take too big of a bite and put too much stress into these specific areas. So now I'm going to go ahead and I'm going to do another 5 units, and I'm going to run it through again. So you can see that it's starting to level out. I'm going to do it again, another 5 units. Now you see that it's becoming even more level. So now what I'm going to do is I'm actually going to alternate the ends of the metal that I start my rolling at. I'm going to pass it through this way first, and then I'm going to take it, I'm going to turn it end for end, I'm going to adjust my roller, and then I'm going to roll it again. In doing this, it's going to even out the stresses, because if you roll it in just one direction, there are a lot of stresses that start to build up throughout the entire field. If you roll it from one end and then flip it over, then you even out those stresses. One thing you do not want to do is now try to roll it this way. If you want to start rolling it this way now, you need to anneal your piece. Also, if you, depending on how far you want to go with this sheet, you need to take and decrease the thickness by at least 30%. I usually do about 50%. It depends on the material, but for silver, I can get away with about 50% reduction before I anneal again. Now, to begin with, the 5 units worked fairly well, but as you get down to where everything starts to level out on the sheet, you might need to back off to maybe 2.5 or 3 units. You don't ever want to put too much stress in the sheet. Just because it's not really hard to turn your mill doesn't mean that your mill is not actually working. You need a little bit of force to run your mill, but you shouldn't have to jump up in the air and put all your weight on your handle to make the mill turn. And now it's just a matter of wash, rinse, and repeat. So you might start getting waves in your piece. And what this is from, it's actually from stopping through the rolling motion. The easiest way to get rid of this is just don't stop rolling. What I mean by that is just like this. If you do this and then you stop to readjust, and you continue this way where you're stopping here and there throughout the field of the sheet, that's what's going to give you those ripples. Okay? Now, whenever you do get these, all you really need to do is increase just maybe a half of a unit, something like that, and then roll it through continuously a couple times, and your sheet should straighten out. So you can see that the sheet is starting to straighten out. So let's see where I'm at. I started out about 70 thousandths, and now I am right at about 35 thousandths. So I reduced it about half again. So if I wanted to continue to thin this sheet out, I would go ahead and anneal now and then continue to roll it. Now, just to recap, I started with a ingot that was 3.5 millimeters in thickness, and now I have a piece of sheet that is less than 1 millimeter in thickness, and I did that with 1 annealing. So it shows you that you don't have to continually anneal the piece over and over again. So 1 annealing from 3.5 millimeter to 1 millimeter, and now this is really good sheet. You can see there's no cracks in it. There's no cracks on the edges. And now I can go ahead and make something out of this. And that's how I take an ingot and turn it into usable sheet. In the description below, you're going to find some links to some of the equipment that I used in this video. If you haven't seen part 1 of this series, I urge you to do that. That's where I take silver scrap and turn it into the ingot that I used here. Part 3, I'm going to take an ingot and I'm going to turn that into usable wire. I hope that you found this information helpful, and if you have any questions, please contact us.